Thank you. I'm excited to talk to y'all today about why you're probably doing web performance wrong. I will admit it's a little bit clickbaity. You're not actually doing it wrong, but maybe you're making your job harder and getting frustrated on the way because you're having little impact, which is always frustrating. Let me make sure my slides are working. All right. So if I were to ask y'all, what's the number one tool you use for making your site faster? I would guess that like 90% of you are going to say Lighthouse, right? It's a great tool. I actually credit it with like giving the web developer community more or making web performance more visible to everyone, which was great. But it's what you need to understand is that it's an algorithm and it's limited, and it might point you in directions that aren't very helpful sometimes. And we're going to talk about Lighthouse, but also the tools that you're probably more used to using. So what do I mean by that? This is a real case that I was looking at the other day, and this was its Lighthouse report. On this website, they had a score of 33, and you can see like there's more than 20 different audits here that are flagged, right? So you're probably thinking to yourself, oh my God, if this was your site. And then the next thing you're probably thinking is, oh my God, do I actually have to do all of these things to make my site faster? And what I want you to do is take a step back and think, what are the primary reasons this website is slow? Is it really minimize main thread work? So let's take a step back. Again, my name is Sia Karamalagos. Although he did such a great introduction to me, I don't really think I need to say much more, but I help make merchants' sites faster on Shopify. You can learn more about me on sia.coach, which is my 11 site, and I have a lot of 11 posts on there, although I haven't done enough lately because I've been working more on our Shopify. It's a performance.shopify.com site in case you're interested about web performance at Shopify. And yeah, all the things. So let's keep going. Let's talk about speed metrics. So in this presentation, I'm talking mostly about speed because that's what we usually think about in performance, but those other things are really great too. But for this, I'm going to focus just on loading speed because the idea is to give you some information about what you could do, which is actually applicable to the other ones as well. So when we think about loading speed, there's three important metrics. The one that's user important to real users is largest contentful paint, which is that last one. And that's when that largest item on the screen or on the viewport is rendered, which gives that user the idea is, oh, this page has loaded. So, and it's the threshold for it is 2.5 seconds for a good experience. And these thresholds were created by Google. This one is more, it's about human perceptions of performance, but also achievability and things like that. But we also have a few other loading speed metrics, and those are time to first byte. That's when that first byte of information comes back from the server. So user doesn't care or doesn't know what that is. They don't care, but it helps us understand what might be going on. First contentful paint is actually that first clue that something's happening. So that's when the first item on the screen is rendered. And these are their thresholds for good. So I'm going to take a step back, and if you've ever used pagespeed.web.dev and you have a site that's popular enough to have publicly available data in this data set, you might see something like this. And you can see at the top that it says, discover what your real users are experiencing. So this is real world data, or we call it RUM data for short, real user monitoring. And it's telling me that, for example, my largest contentful paint is 4.8 seconds. That means that 75% of my users are experiencing a largest contentful paint of 4.8 seconds or faster. And so you can see we have our core web vitals on the top row, and on the bottom row, we have those extra metrics plus one that's about to be deprecated or semi-deprecated. But we can see this data. So this is how my real users were experiencing that same website. And this, again, is the Chrome user experience report if you don't know much about that. So at the top, I have our same little kind of waterfall diagram. And at the bottom, we have our example with the real user data mapped to it. So you can see that time to first byte, I've extended that row out to 2.4 seconds because that was a number on the previous slide. FCP is 3.8 and LCP is 4.8. So what's the primary bottleneck here? There is no world in which you can achieve a 2.5 second LCP with a 2.4 second time to first byte. It's just not possible to do your entire first render and your largest contentful paint within 0.1 seconds. It's just not possible. So if I were to instead, so the first two on the screen are what you've already seen. And on the bottom, what I've done is I've pretended like I've made my time to first byte good, and then I've mapped FCP and LCP so that you can see, what would they look like if that time to first byte was faster, because these are sequential. You can't render the page until you get the bytes from the server, and you can't render the largest thing until you've actually rendered the page. And sometimes those can happen at the same time. But we can see now that FCP it's still a little bit slow. It's only 0.4 seconds slower, and LCP is about 0.7 seconds slower. So they still have a little bit of issues, but that biggest contributor was actually time to first byte. So looking back at our Lighthouse report, where would we have found that out in here? Well, what's really interesting, which it took me a while to figure this out because I was looking for it, because I ran it twice because I was trying to explain essentially a similar point to someone else. And it didn't even pop up in this Lighthouse run. It actually, in this specific experience, we actually had a good time to first byte. So it didn't even trigger what is usually happening in the real world. Additionally, remember, so that was probably our biggest issue, but because I know there's a little bit of issue with FCP and LCP, my guess is the other two are these other two audits. That's what I think they call these things. But the largest contentful paint might have been lazy loaded. That's something that happens a lot on Shopify sites, although to be fair, this is not a liquid Shopify site. And then render blocking resources is a common reason why first contentful paint is slow. All right. So let's take a step back and let's learn about these two different types of testing. So what you see on here is what we've just seen. On the left is that top part of php.web.dev, which is technically the Chrome user experience report, which is your real user data. And on the right, we have our Lighthouse report that you've probably seen a lot, right? It's this Lighthouse report. You can even kind of see in the little gray area, you can see that it was run on an emulated Moto G Power phone using a slow 4G throttle connection, but it's run on a server somewhere and it's just a single run. So it's only a single point of data. Whereas on the left, it's an aggregated data across all of our user experiences. On this page, you can see an internal report we use at Shopify that is real user data. So we collect data with our own script and we can run it across our site. So I like showing this because it shows that, oh, now I'm going to break it down by page and device type. So I can see that, the collection page has a big problem with CLS, which is right down here, but the desktop page has less of an issue with CLS. So you can see these differences by page and by device. Oh, you know what? It's directional clues. And on the right is a network diagram from DevTools, which if you've ever run, that would be considered lab testing. It's a single run. Left is aggregation, right is a single run or lab test. Again, on the left, this is just another way to see Chrome user experience report data. It's this cool site called Trio. Their site speed report uses the Crux API. And I like how you can see monthly data in there. But it's aggregated data from Chrome specifically. On the right is your performance panel in DevTools, which is also another lab testing tool. So there's two different types of testing. There's RUM, real user monitoring, also called field data. And then there's lab testing, which is also sometimes called synthetic testing. Neither one of these is better than the other. They just have their own uses. So like you wouldn't use a hammer when you need a screwdriver, and the reverse. So what are those differences? Example tools, again, Chrome User Experience Report is for real user data, but you can also collect this data yourself. A package I use a lot for collecting it myself is the Web Vitals NPM package, which is maintained by the Chrome team. There's also Boomerang, which is an open source version of Akamai's Impulse product. And then there's also, if you wanted like a paid service, well, there's Impulse, but there's also SpeedCurve, which I really like. And lab testing, it's those tools like Lighthouse that you're probably used to. PageSpeed Insights, just that bottom section, the one that has Lighthouse in it. Web page tests, your network diagram, your performance tab in DevTools. Those are all lab testing. So RUM is great for when you want to see how real users are experiencing a site. and reveal those real world bottlenecks that might be hidden in a lab test. Like we just saw, what was actually hidden was that there was a time to first byte issue. Lab testing, though, is great for detailed data, and you can more quickly debug and retest. So their cons are kind of the mirror of each other. RUM is, there's going to be limited metrics. You're only going to have these handful of aggregated metrics, and it's hard to debug. You can't just like go make a change and quickly see if that probably fixed the issue. Instead, you actually have to use lab testing for that. But of course, on that side, it can hide those real world data, and it's not representative of real user experiences. We're using servers to emulate an experience, or we're using our own powerful desktops and whatnot to measure. So what are some of those example observations? With RUM, I can say, oh, LCP is slow on, the product page, or CLS is bad on the home page on desktop, but not mobile. On lab testing, though, what I can do is I can use those, what I call directional clues, to figure out if, I can see now that the LCP is lazy loaded, or that 5 files are render blocking. So maybe I should figure, dig in deeper on that. Or that sales banner is shifting content down. So when I debug, what I do is I use real user data and those gaps between time to first byte, first contentful paint, and largest contentful paint to narrow down the most likely issues. A very similar concept is LCP subparts. And Estella Franco has a great talk she did at the Perf Now conference, and Debug Bear has a great article about this as well. I usually have these specific metrics at hand, so this is the method I use, but it's a very similar concept. So what do I mean by that? When we have these 3 metrics, if you have a problem with one of them, it's usually specific to that issue. So if I have a problem with time to first byte, you might ask yourself, why might my server be responding slowly? If instead you have an issue with first contentful paint, you might need to ask yourself, what's preventing the render? Do I have a lot of render blocking resources? Am I using an anti-flicker snippet that's hiding the page because I have A/B testing turned on, or something like that? If your LCP is slow, then you might ask yourself, why isn't that LCP element showing up faster? Is it because the image was lazy loaded? Or if it's text, am I blocking the font until the web font comes in? So there are different issues depending on which part of your speed is broken. All right, so now that you know that generally, let's take a look at some examples. So in this example, this is actually an example of a great performance. There's a fast time to first byte, first contentful paint, and largest contentful paint. This is Crux data from that Trio tool. In this second example, we can see that this is somewhat similar to the one I've shown you, is that time to first byte is 1.7 seconds. That's pretty slow. And so it's actually impacting the other two, even though there's only a gap of 0.6 seconds to first contentful paint and 0.4 seconds to largest contentful paint. So while all of these are yellow, it's actually time to first byte that is the bottleneck here. So I look at server issues. In this next example, this is an easier one because the first 2 are actually green, so we know it's just the largest contentful paint element. So I'd look specifically at that element to see what's going on. This next one, you can see that FCP or LCP is only 0.3 seconds after FCP. So FCP, or first contentful paint, is the primary bottleneck. And finally, a lot of cases aren't going to be quite so cut and dry. You might have multiple issues. So on this one, time to first byte is good, but both FCP and LCP could be worked on. All right. So those are some examples, because this is probably the stuff that you've seen less of, and in the past you might be maybe seen more of, like just the Lighthouse stuff. So I use that information and then finally bring up my lab tool to dig in deeper. So once I have those directional clues, I will dig in deeper. So for Shopify sites, Shopify uses Liquid, but of course there's a lot more. We actually have a server side. It's not static generated, but we do use Liquid. And I've had an article about how to optimize Shopify sites. A lot of these issues are going to be very similar to the general web if you're not using a front-end framework. Although the issues for time to first byte being slow on on a static site might be more, for example, around your provider. So like if you're using GitHub Pages, I don't think that's on a CDN, but if you use like Netlify, then there's a CDN for that, and also Cloudflare Pages. So depending on your server service, that could impact your time to first byte. But the FCP and LCP, especially for e-commerce sites, might be actually quite similar to the common reasons why a site might be slow compared to the Shopify sites. So of course, this is a whole nother talk and we only have 22 minutes. So I'm not going to go into all those different lab tools. But what I'm trying to tell you is don't start with just Lighthouse, or don't start with your lab tool. You might go down the rabbit hole with minimizing your main thread work, which is still very important and a valid issue, especially considering, because I think this site has IMP issues as well. But instead, I want you to start with that real user data, get your directional clues, and then dive deeper with lab only on those specific issues. Essentially, try to get your heavy hitters first. Don't worry with those micro optimizations first. And then in the end, hopefully you'll have more time to focus on that hobby that you've been neglecting. So thanks again. You can find out more about me on sia.codes.